Hello everyone, welcome to our second video on classification algos. In this session, we'll explore another popular ML technique for classification that is called K nearest neighbors or KNN. Do look at this name, K nearest neighbors. This is a very simple but effective algo for classification task, and what we cover here is how KNN works. What are the typical scenarios where you can use KNN, and then we'll actually try and look at this iris dataset and how actually we'll have a walkthrough of KNN on that dataset for classification. There is another topic that will be tested, which we call cross validation. We'll actually see more about it in next few minutes. But the idea here is, rather than having a very simple test train split on your data set, you kind of divide them into groups, multiple groups, and use all other groups for training and test on one of that, and then keep actually kind of rotating it. So we'll see some of that. In this video, your working of KNN, some differences or similarity with decision and scenario where it can be used. These will be tested in your exam. Just for the sake of completion and kind of prepare you for in your path forward to your data science journey, beyond and above your CBSE board exam, I have actually added a couple of additional things which are essential, but you don't need to kind of memorize or prepare them from exam perspective. That will be your evaluation metric. So the way for regression, you used mean absolute error, root mean square error, or actually R square or adjusted R square for finding out the goodness of fit. Here for classification related things, accuracy, confusion metrics, accuracy is a very simple accuracy, is not sufficient when you just look at the number of correct classification count of that. There are more involved metrics which are actually around precision recall and FS code and some other subtle variations. So we just touch upon that. We'll actually take a simple example and go through that calculation. Because if some of you will be kind of looking for some short-term project opportunity, and if you in case you get into some kind of interview related setup, you might be asked about how to evaluate, and you need to be familiar with precision recall, but nothing from exam perspective. And then actually we'll have one of those hands-on for where we actually use KNN to see how we can model our iris data set, and we'll end this without question mark through it. So the way we are doing for regression, classification, and decision trees, right? Let us actually have one formal definition of what is K nearest neighbors. So at the very surface level, right? We're one of those supervised machine learning algo that we use for classification as well as regression. But keep in mind, KNN is mostly, or in practical term, it is used only for classification. Your decision tree is kind of popularly used for both regression as well as classification, and you might be tested on both of these topics in your exam. So you need to keep in mind that KNN, theoretically, yes, it can be used for both classification and regression, but practically KNN is used only for classification, while decision trees are having practical usage across both. The idea behind KNN algo is you might have seen this in typical behavior, right? You are known by the set of friends that you have, right? So many a time what happens is we have our behavioral preferences or many other trait where you like being with similar kind of people in our thought, deed, and whatever we do with our life. So in that sense, KNN is primarily built around this particular strategy. That if I can kind of group, right, similar data points than the one that we have, where we want to make prediction, uh, you know, uh, we can actually make some educated guess, and in this particular case, data-based guess or data-based, decision making. Let's keep guess from formal definition. Let's call it data-based decision making with very high accuracy or with very high confidence. So that's the intuitive idea, that you actually look at similar terms, similar data points, and if you know about those data points, then actually you can be sure that that's how the kind of level that you can put here. I mean, a very simple example. If in your class, right, you might have seen some of those lighter moment, right, where people say that who are your friends, right, and if they are high scorers or something like that, then you actually see many of those comments. We'll not get into this particular example, but the idea is same, right? That depending on your the data that you are having, if you find the similar looking data points, you group them, you can actually make decision about uh, unknown data sets. The example here that you are seeing, and I would like to point out another thing. I'm not sure you paid attention. Otherwise, you can actually go to the previous video and watch it again. The decision boundaries for decision trees, right, were non-linear. In case of here k nearest neighbor, you look at the color, right? You can assume a straight line somewhere between this circle, blue circle, and this colored rectangle, right? Sorry, triangle. And then you start calling, say, triangle, anything that is up, and then you start calling, say, circles, anything that is below that. So the decision boundaries in case of KNN will be, linear. What you can also see is all your data points will not be predicted correctly. So you might see some actually, blue circle in those triangles and vice versa, and those will be incorrect prediction, or your model's inability to kind of make correct inference about them. So hope you have got some idea. KNN as a word, that is K nearest neighbor, is one of the classification algo that can also be used for regression, and its major working is kind of finding similar data points and then making an decision point about those data points, right? The data that you are right now having. We'll actually spend some time, seeing how this K nearest neighbor works. So basically, there are, some whenever you are actually trying to make decision about a new data point, what we typically do is, you can actually have distance metric appropriate for the kind of data set that you are having. For sake of simplicity, let us assume that all your data points are numeric in nature. But that is, not a constant. KNN can work even on categorical, data set as, independent variable or features. So basically what you are doing is, when you are actually, having a new data point, let's call it a query, you are, trying to find out all the other points, right, which are nearest to it, right? And so basically you are having some kind of distance measure, right? So basically you have distance from one to the other, right? and then actually you are kind of sorting in some way. So once you have actually some distance-based grouping, you look for getting the k nearest neighbors, right? And once you have got an aggregate measure of distance, it is just kind of taking the top top n k's, whatever is you are looking for. K here is actually user chosen behavior. So you can say that 5 nearest neighbor, or you can say 10 nearest neighbor. So in that case, decision will be made based on top 5 or top 10 nearest data points. And once you are there, you actually either look majority vote or average it out, right? So, say you got 4 of one type and 1 of another type, right? Then actually you can make your decision either by majority, or you can actually average it out. So the steps are simple. There is a way of getting distance, right? Calculate distance. Then you aggregate and get the top k, the nearest one, and then you use actually some kind of majority vote out there, or average. K here is again, as we said, we can just have 1, 2, 5, 10, depending on what works best for you. Typically, something above 5, is what is used, but there is no fixed definition of it. Now you'll also test it on one of the key characteristics of KNN. So, what is happening in case of KNN is there are not many explicit training loops, right? So in your it is basically memorizing the data set that is available to you, and whenever you are doing prediction at that point in time, it looks at the data point with some heuristic, and then try and find the based on your definition of k, that one nearest point, and then it try and make the prediction, right? So lazy learning is one of the key characteristics. In a way, it helps you save a very involved training process, but keep in mind your inferencing can be very slow, because at runtime you have to look at so many decision points. Another good thing is actually this algo doesn't make any assumption about what kind of data set you need to have. So these are non-parametric, and so algo in that sense is very sort of versatile. As you might have seen, it is simple and intuitive, no training phase, good for multi-class problems. So, when you are actually looking for certain scenarios where we have to, number of classes that you have to predict are very high, k nearest neighbors are known to do well. Say, for example, disease classification. You could have hundreds of digits, right? So even more than 100, right? Can be used. No assumption about data, which was the non-parametric part of it. So lazy learning, non-parametric learning has key characteristic. Advantages, disadvantages we saw. Of course, it will be slow. Imbalanced data set. This is another thing that will be tested. So if your data set is having imbalances, when so if you are having say binary classifier, say spam versus non-spam, that lot of emails in real life will be non-spam. So you'll usually be having a lot of very large amount of data which is normal, but the spam will be relatively lower, right? You can go to more extreme, right? Say for example, if you are looking for say number of time market has crashed versus number of time your market is regular. If you are trying to make prediction whether your market will crash the next day or not, if you look at your trading history, then very few, if you define the definition of crash as say more than 10% in a day, historically you'll just be having handful of data points, right? So, when you just have handful of data point, right, for one of the classes that we call minority classes, while your majority classes could have a lot of them, then k nearest neighbor is performed very poorly, and you might have reason to it. What it is doing, there is no training phase involved. eventually when you have to make prediction about the data point, what all it does is actually it has memorized certain characteristics and made internal representation of data based on intuition of distance. And only thing it is doing is it is actually trying and find out k neighbors, and then using majority or average to make a decision. So when you are actually data itself is like 1 million positive versus just handful of negative, or 10,000 positive versus just handful of negative, and if you have to make a binary decision of good versus bad or whatever it is, then they are known to have very disastrous result, because most of the time it will actually predict the majority class. So in a way, its accuracy overall could be good, but it will be unable to find out the set of data points which are represent the minority one. Just to close, just to kind of close this. So if you try and build predictor for market crash, right? Anyway, you know that there are 252 trading rate in a year, and if you have a deflation of say 10% or more, then in several years you just get one. So say if on an average every 5 years, if you are getting one crash, then you know that 1,000 of one, it means the 99.99% your model will be accurate. But its ability to find out the one when it really market will crash will be very, very poor. It will only be able to do very poorly on that. Outliers. So again, it will be sensitive to outlier. Why? Because it uses average or some of those techniques, and that can actually help you distort the overall result. Curse of dimensionality. So again, what happens is when you are having larger number of features, this computation becomes difficult, and it becomes overall slow and its performance degrades. So that's another thing that you need to keep in mind. Distance metrics, and there are always there are computations cost, as well as in some cases there are trickier ways of getting it. So if you don't have right intuition around distance in those data set, it will work poorly. Just key differences. KNN is memory intensive. It is effective with a smaller data set. DecisionTre are better for larger data set. They are interpretable well. Yeah. Just keep some of these common things in mind. We don't have to keep all of these. You can actually go through and scroll through it. So when to use KNN, right? Effective scenario, small to medium data set, right? What are its limitation? Computation cost is high, poor performance for high dimensional data, right? And we have seen some examples. Okay. So we'll actually rest our KNN related discussion here. Let us go to the cross validation. We'll quickly introduce the cross validation. The idea behind cross validation is to effectively use all your data points for your training process. One very common thing is you have 80% split for test, 20% split for train. Rather than doing that, say actually if you divide your data in 5 folds, right? So if you're having 1,000 data points, you have 200, 200, 200, 200, right? Then what you do is you fix the 200 first 200 as a test and train on the remaining 200 into 4, and from there on you can actually choose the next as a train and the remaining 4, and that way the cycle continues. So since you are actually kind of going to average across all these smaller data set, K-fold cross validation is known to have low bias, right? These steps are actually pretty straightforward. You might look at this example, right? So you have done a 5-fold split of your data. You use the last 4 as train, first one as test, then second one as test, remaining as test, train, then third one as test, either side as a train, and fourth one and fifth one. So bias reduction and efficient use of data. Sometimes you'll not be having a lot of level data. So this is actually one of the ways where you can actually, your model have a chance of looking at these at least partially. Okay, so we'll just talk about precision recall and FS code with a very simple a spam versus not a spam email. So there are two things, right? say you have a you have say 100 emails, right? And 80 of those are actually spam, 20 of those are not spam. So that's the actual spam and actually not spam. That's your actual data set, right? Then there are prediction. Look at the vertical one, right? So this part, right? So if you actually look at this one, right? So if your model also predict, right, it as a spam. So this commonality, right? If you see this one, right, where it is actually in a spam and model also predicts a spam. This is what that we call true positive. In a similar way, if it is not a spam and your model also predicted not a spam, so that's the true negative, the fourth one, right? And otherwise, what it is, if it was actually a spam and model didn't predicted it, so it means that it predicted negatively and that was false. So that is one that we call false negative. If you predicted it positive, but if it was not, so you call it false positive. So this false, true you can understand, right? Your model predict it is actually that, so it's true positive. Negative for binary is your model predicted to be negative, it is actually negative, true negative. So true positive, true negative, you can get it. False negative will be what? Your model is predicting it to be negative, but it is not. So that's the name false negative, right? So TP, FN, FP, TL. Keep this in mind. So say that you have collected some data set and then you are having TP, true positive, false negative, true negative and false positive in this way. Uh, so the definition of you can actually you can look at, right, another view of it, right? So we already explained about it. Now formula for precision, right? So precision is a way of getting proportion of your uh, data set, right? Of whatever category it is, you are also making it in that category, right? So read this line very carefully. The proportion of email predicted as a spam that are actually a spam, right? So true positive and what all you predicted, true positive plus false positive. So the precision is this actually, precision is this line, right? So I'm facing some issue. So your precision will be this line, right? You are making true positive as 40 and you have made total 50 predictions. So true positive is 40 and 40 by 50, right? Sorry, false. So you are looking at your prediction, right? I'm sorry. You are looking at your prediction. So this one. So your precision is true positive TP divided by TP plus false positive, right? So that's your 40 divided by 40 plus 545. You got your precision. Uh, your recall, right? For recall, you are looking at true positive and false negative. So here you have true positive and here you have false negative, right? So 40 divided by your 40 plus 10, right? So that's the horizontal that we are talking about. So this is the proportion that you have been able to correctly get. Once you get the precision and recall, F score is another metric where you do harmonic mean of it. So 2PR by P plus R. And harmonic mean will always be between 0 and 1. Higher the better. So 0.84 means F score of 84. If you get another model which is having a score of 90, that is a better model. Okay, so we talked about precision, recall, interpretation. We have already seen about random forest, some example, we'll leave it. So this is the decision boundaries, that we'll actually eventually, see for our iris data set, right? How we have got it? Let me actually, quickly get through our code. So, uh, As long as, so like DecisionTre, K neighbors classifier, right? So this is the SQL library that you can use. Other steps are, more or less the same, right? So you import the data set. That is the first part, right? And then you simply load your data set and call your trend test split on data and target part of this data set. And then you use your, K value here, right? So KNN is K neighbors classifier. And how many K? 1. 3, right? So you can look it here. You can experiment with various, K value. So this is actually, 3 neighbor classifier, right? K is 3 here. So then you are simply calling fit, and then, once you have called fit, you can actually get your score out here, right? So yeah, I mean, on this tiny data set, it almost fits everything, and it was expected. Okay, let's get back to our document. So now we'll actually, do a quick, review of some of the questions that you can expect. So what are K nearest neighbors used for? And we also, tried reasoning about it. It can be used for both regression as well as classification. Which of the following statement is false? K nearest neighbors use proximity for prediction. Yes. K nearest neighbor takes a majority vote on K data points. Both could be true. K nearest neighbors can't be used for regression. So, obviously this is false, right? What are some of the advantages of KNN? Easy to interpret, no extra training step, lots of memory needed. Lots of memory needed is disadvantage, right? So advantage will be A and B. KNN works well with imbalanced data set, no. We tried emphasizing it. Cross-validation happens do what? Remove, not remove, it should be reduce bias and help to test tune parameter, yes. But remove is incorrect. Then you can expect sort node of advantage, disadvantage, how KNN works, what is cross-validation, and sort node on disadvantage of using KNN steps, right? So you can actually emphasize on some of the key points that we talked about. You might be asked to describe, how you can use the K-nearest neighbor for multi-class classification. So that's the same, right? You look at the distance calculations, find out the K-nearest neighbors, then look at majority voting, right? We already talked about it. And if there are tie, actually, you can figure out a way of breaking that, right? So weighted voting is the one that you can do. Great. So I think we have come towards the end of it. And with this, we have also covered large part of the classification one, right? The next one is more about unsupervised and a very, very popular ML techniques in that space that we call K-means clustering. So let us actually meet again with our next video on unsupervised as well as K-means clustering.